Alright, so we'll go over practice 7-2. So I had asked you to do numbers 1 to 8. So let's see what that's about. Problem number 1, it says cosecant of x over cotangent of x plus tangent of x. And we want to show that that's cosine. First thing I'm going to do is write cosecant as 1 over sine. Denominator, I'm going to write cotangent as cosine of x over sine of x plus sine of x over cosine of x. And we need to get a common denominator. So this will turn into 1 over sine of x. We're dividing by the denominator, cosine squared of x plus sine squared of x, all over sine cosine. Well, keep change flip. Cosine squared plus sine squared is just 1. And when you multiply these, the signs cancel, and we just get cosine of x. For problem number 2, it says sine cubed of x minus cosine cubed of x is equal to 1 plus sine of x, cosine of x, times sine of x minus cosine of x. So really, for a problem like this, I'm not really sure which side would be simpler to use. It really doesn't matter which side you choose. And it looks like on the answer sheet I used what did I do? I chose to factor the left side. So you have that in the answer sheet. I'm going to show you how to make the right side look like the left. So I'll start with the left side here. First thing let's do is let's FOIL it out. So we'll get sine of x minus cosine of x plus sine squared of x, cosine of x, minus sine of x, cosine squared of x. So we can't really do anything with the sine of x and the cosine of x, but I know that sine squared plus cosine squared is 1, and I have to get sine to the third and cosine to the third. So if I can convert this to a cosine, cosine squared times cosine is cosine to the third. So instead of sine squared, I'm going to write 1 minus cosine squared. And I'll do the same thing with this. Instead of saying cosine squared, I'm going to say 1 minus sine squared. Now let's multiply everything out and see what we get. We get sine of x minus cosine of x plus cosine of x minus cosine to the third of x. Well, that's nice because that's what this is. I think I said third and I wrote 2. Minus the sine of x plus sine to the third of x. So it looks like what we have here, this sine cancels with this sine, this cosine cancels with this cosine, and we wind up getting exactly what we wanted. That's what the left side was. If you chose the left side to start with and factor that, you can look at my work that I posted. Problem number 3 says 1 over sine of y minus 1 minus 1 over sine of y plus 1. We want to show that that's equal to negative 2 secant squared of y. First thing we'll do is get a common denominator. And what that would be here is sine of y minus 1 times sine of y plus 1. So I'll multiply top and bottom here by sine of y plus 1 over sine of y plus 1. And then I'll do the same thing over here. I'll multiply by sine of y minus 1 over sine of y minus 1. And we'll have a common denominator. On the top here, this turns into sine of y plus 1 minus sine of y minus 1 all over the common denominator of sine of y minus 1 times sine of y plus 1. And remember, we want to turn this whole thing into negative 2 times 1 over cosine squared. Well, if the bottom's supposed to be cosine squared, somehow we're going to have to take what we have and convert that to cosine. I'm going to FOIL out the bottom, sine squared of y plus sine y minus sine y minus 1. And let's distribute out the top, sine of y plus 1 minus sine of y plus 1. It looks like we get on top 2 over sine squared of y minus 1, which kind of looks like the Pythagorean identity, but sine squared minus 1 is equal to negative cosine squared. And 2 over cosine squared is equal to, we could just write secant. Here, let me show you here. This is really just the same thing as saying negative 2 times 1 over cosine squared of y. And 1 over cosine squared is the same thing as secant squared of y, which is what we wanted. All right, so that was number 3. Number 4. Number 4 says we have 1 minus 2 sine squared of x plus sine to the 4th of x is equal to cosine to the 4th of x. Now we have to convert the left side to just have cosines. So I'm going to be using my Pythagorean identity because that goes from sine squared to cosine squared. So instead of saying sine squared here, I'm going to write what it's equal to. 1 minus cosine squared. And instead of saying sine to the 4th, I don't know what that is, but I could write sine squared times sine squared. And then instead of those sine squareds, I could write 1 minus cosine squared. Let's see what we get now. Now that everything's in terms of cosines, well, that's what we wanted. We wanted cosine to the 4th. Let's see here. We get 1 minus 2 is negative 1, plus 1 would cancel. So these constants are all gone. 2 cosine squared minus cosine squared minus cosine squared, well, these would all cancel. And you just wind up with cosine to the 4th of x. Problem number 5. We have tangent of x plus cosine of x over 1 plus sine of x. We want to show that that's equal to secant. So let's get a common denominator by multiplying this by 1 plus sine of x over 1 plus sine of x. And we'll get 1 plus sine of x times the tangent plus cosine of x all over 1 plus sine. We could distribute out the top. Top's going to be, this is going to be, let's see, tangent of x plus tangent times sine plus cosine of x over 1 plus sine of x. I know tangent is sine over cosine, so let's convert that. All right. And it looks like the top's going to have a common denominator of cosine of x. So these fractions have a common denominator. I'll have to multiply this by cosine over cosine to get at that over the same denominator. And we get sine of x plus sine squared of x plus cosine squared of x all over cosine. And we're dividing that by, we're dividing that whole top by 1 over, we're dividing the whole top by 1 plus sine of x. Well, this is a Pythagorean identity. That's just 1. So we really just have 1 plus the sine of x over cosine of x. And we're multiplying that by 1 over 1 plus sine of x. 1 over cosine is secant, which is what we wanted. All right? I just did a little rearranging. I mean, this is sine of x plus 1. I wrote 1 plus sine of x. It's the same thing. All right, so that was number 5. We'll go to number 6. Number 6 says we have the tangent of x plus secant of x over secant of x minus cosine of x plus the tangent of x. And that's whole thing is equal to the cosecant of x. I look at this whole thing as just like a necklace. One of those really thin necklaces that we have to untangle. First things first, let's convert to sines and cosines. So sine over cosine plus 1 over cosine. And we're dividing that whole top by 1 over cosine minus cosine plus sine over cosine. Well, the top we can combine now. This is just sine of x plus 1 over cosine of x. And the denominator, let's get a denominator with cosine of x on the bottom. So I'll have to multiply this middle by cosine of x over cosine of x. So the denominator turns into 1 minus cosine squared of x plus sine squared, just sine of x, all divided by cosine of x. We can keep change flip. I have the top divided by the bottom. All right, and we're multiplying the top and bottom by cosines. So really, we're down to this. Using just pretty basic math, we converted to sines and cosines. We got a common denominator multiplied by the reciprocal. I mean, that's pretty basic algebra. And think about what we want to get. The other side was cosecant. That's 1 over sine. So it might be a good idea to get all sines on the bottom. 1 minus cosine squared, we've seen a few times already. If sine squared plus cosine squared is 1, then 1 minus the cosine squared is secant squared. I'm sorry, is just sine squared. We get sine of x plus 1 over, we can factor out a sine of x. And look at this. We do see the same trig function here. It's just like having x squared plus x. So I mean, you could factor out an x, right? So we could factor out a sine. These would actually cancel, and we get 1 over the sine of x, which is cosecant of x. After I do a few of these, I'm sure it'll be a lot easier. Number 7 and 8, those are pretty straightforward. It's like the last example we did, where we have sine of x is equal to 3 cosine of x. we want to get a single trig function equal to a number. Well, let's get that 3 by itself. We're multiplying by cosine. Divide by cosine. Sine over cosine is just tangent. So we get a single trig function by itself. For problem number 8, same idea here. We have cosine of x is equal to cotangent of x. Let's get a single trig function by itself. I'm just going to divide on both sides by one of them. It doesn't matter which one we do. I'll just divide both sides by cosine. It doesn't matter. And we get cotangent, which is cosine over sine, and we're dividing that by cosine. So let's keep change flip. And we get 1 over the sine of x, which is cosecant. All right, so that takes care of practice 7-2. Have a nice day.